I welcome you all for this wonderful session of applications of. So it was organized at T.John College in association with IQAC and NoviTech. Okay, let's enter the topic. And before, I would like to introduce ourselves. So we are NoviTech is a technology company specialized in product engineering with main focus to industries, automotive and robotics and industrial electronics. And we are doing a academic project training for both engineering and arts college students in a variety of domains like artificial intelligence, Internet of Things, embedded systems, Java, and power electronics, power systems, etc. And we are conducting a lot of faculty development programs in reputed engineering colleges in Kerala and Tamil Nadu also, and hands-on workshops and in-plant trainings and internships and product development for some top industries. And our head office Ramnagar, Coimbatore, and our another one branch office located in Kallur, Kochi. Okay. So first, let's enter artificial intelligence. Okay. So artificial intelligence. So intelligent means it's our sixth sense. So because we are a human, we have some six basic senses. Yeah. And the basic five senses is based on our organs. So it's like our eyes, nose, and ears, and skin, like that. Okay. So and our sixth sense, that's called the intelligent power. Okay. So that intelligence power. So we need to create that intelligent power. We need to give that intelligent power to the machine with artificially. Okay. So that's called artificial intelligence. Okay. So we need to create a intelligent power artificially. So that is called artificial intelligence. So basically, so we are see something in our environment, in our surrounding, okay, using by our eyes. Okay, so that's a visual communication process. The same process the machines need to do that. Okay, so using by some image processing technologies. For example, if you are see something, see any one of the objects means, so our brain automatically understand what is the object is this. Okay, so it's based on our neural network process, and it's based on our knowledge also. Okay, so the machines need to do the same process like our human. Okay, and that's called image processing. Okay, so this also under the artificial intelligence technology. And then next, so we are communicating with each other using by some languages, so like our English language and Hindi or Malayalam and Tamil, like that. Okay, so these are the some communication language, communication tool. And if you talk something to anyone, so they can understand your words and sentence and language, like that. Okay, so they can understand and exactly they can respond for that your talking. Okay, so that's called language processing, natural language processing, NLP. So it's also under the artificial intelligence. And next, if you see some steps like that. Okay, so steps or some objects in front of your leg. Okay, so suddenly you are choosing some other options. For example, if you are see the steps means, so it's automatically move your leg, it's in a up condition. Okay. So based on a visualizations, we need to take a action. Okay, so that's called robotics. So based on visualizations, based on the vision, we need to take a action. So that's a robotics. It's also under the artificial intelligence process. Okay, so basically so humans have some knowledges, and we get the knowledges from our experience, past experience. That is very important one. Okay, so and before entering to the deep artificial intelligence, I would like to explain about this application. Okay, so first initially we all know about the refrigerator. So refrigerators, we have some normal refrigerators also, and that refrigerator have a lot of sensors. Sensors means it's sensing device. It's used to sensing the surrounding. Okay, so we can sensing the surroundings using by these types of sensors. So in our mobile phone, if you take our mobile phone, that mobile phone has have also lot of sensors. So it's like IR sensor and proximity sensor and MEM sensor. So there is a lot of sensors are available in our mobile phone. Like that, our refrigerators also have means some temperature sensor and some cooling production sensor, I guess, and some door lock sensor. So there is a lot of sensors are so we can easily Internet of Things. I hope all of you have some basic knowledge about the Internet of Things. So things means it's nothing, it's a physical object. Okay, so every physical objects are called as a things. Okay, so Internet of Things, so we can say like that, Internet for things. So we need to add the internet facility to any one of the things. For example, table, if you take a chair, easily get the informations about the refrigerators from everywhere. So like from our in our mobile phone, so in our some PCs, like that, some Android applications. So see, so that door open close sensor, that so sensors is identify the door opening and door closing. So we can easily identify the door opening time also. Okay, so it's simple. So after applying the Internet of Things, so we can get the informations about the refrigerator from everywhere. So what are the objects inside of that? Okay, so this like, okay, it's a basic. Okay, so normal electronic process, and then if you are attached the Internet of Things process, and another one process that's called artificial intelligence. The third process, artificial intelligence. If I am apply the artificial intelligence to the refrigerator, so what he can do, so what it can do means, so it's simple. So here we need some two inputs. So first one is a previous usage history, so that's called a data set. Okay, so data set, previous usage history, so I talk it about later. So and next, current available products data in fridge, this is the input data. So first part is a data set, there is a previous data, and then next the input data. Okay, so and after, it's a current data, and after that finally we get some food recipes list, so in our mobile phone. For example, in your refrigerators, we have only some tomatoes or some onions, like that means. So what we do with that groceries? Okay, so this details is available. So these details we can get from this artificial intelligence. So the basic thing, so first initially we need to give us some previous usage history to the machine. Okay, previous usage history and some recipes list to the machine. So this is a training part, we need to train the machines using by these types of informations. And after that, the input data means it's a current real-time data. Okay, so what are the things available in the refrigerator? This is our input data. This input data is compared with our previous usage history, and based on the things we can get a some food recipes list. Okay, so what we do with that types of vegetables and fruits, available vegetables and available fruits. Okay, so and after applying it, so we can get these informations from our mobile phone, in our mobile phone, so using by the internet of things technology. So the normal intelligence. So because humans are the best AI um, products. Okay, so that machines also need to mimic the human being. So that's why, so we apply some algorithms and apply some programmings to the machines. Okay, so and next, this artificial intelligence and methods, some methods for giving a knowledge to the machines. So first, initially the artificial intelligence, so it's engineering of making intelligence machines and programs. So it's one of the branch for making intelligent machine. Okay, so and it started from 1950s. And then machine learning means it's nothing, so basically learning. So see, so basically learning, so we learning something from our past experience. The experience is the matter here. Okay, so from our parents and from our teachers, and then we are getting a knowledge by our own itself. Okay, so these are the some experience through our some online videos or some books, or some real-time examples. So based on this, so we can get a knowledge, and these all the things are only happened by a experience. Okay, so totally the machines, sorry, the humans getting a knowledge from the past experience. As like that, machines also need some experience for analyzing, for prediction for these types of process. Machines also need some experience, but that machines cannot get a experience, naturally. Okay, so because machines knows only the zeros and ones, so that's the binary means it's a power supply, that's all, zeros and ones power supply. Okay, so the machines cannot get that experience naturally. So we are a human, we need to give that experience power to the machines as an instruction. We need to give some instructions, we need to give some experience to the machines. So that's why the machines learn from humans instructions. Okay, so after getting a knowledge, after getting a experience, that machines can easily predict, easily analyze better than human. Okay, so that is the important one. Okay, so machine learning is one of the type for giving a experience to the machine. Okay, so and this is the subset of artificial intelligence, and it was started from 1980s. Okay, so and next, deep learning. So I will explain about the deep learning. So machine learning and deep learning, so there's no any biggest difference. So simple. For example, if you have some normal experience, some low level of experience, some low level of data, okay, so then the machine learning is enough. Okay, so consider if you are going to any one of the place, any one of the new place. Okay, and you are meet some people, some 3 or 4 peoples. Okay, so and they are introduced themselves to you, and you get some knowledge, so you get some features means some clues about that persons. Okay, and they will introduce themselves, means a name and place and some knowledge, qualifications oriented. So these details you can get from them. Okay, so there are only 5 peoples, so you can easily understand the name and the qualifications of that 5 peoples. So because there is very less data, 5 peoples means it's very less data. Okay, but if you are enter into an auditorium or any one of the some crowded place, okay, and there are 100 peoples are there, and that 100 peoples, all the 100 peoples are introduced themselves to you. Okay, so we can't we can't understand the name, we can't mind the name, and we can't mind the some features and qualifications of the details about the crowds. So because there is a some biggest datas. Okay, so biggest data means there is a lot of peoples, so lot of data sets, so we can't understand, so we can't mind it clearly. Okay, so that's why here we using the deep learning. Okay, so by using the normal machine learning concepts, we can't get a clear idea about the data if you are given a huge amount of data sets. So that's why we enter into the deep learning. So the deep mentioned that. Okay, so and it was started from 2010, and see that, so learning based on deep neural network means it's simple. Our brain humans brains also running by the neural network. So this deep learning is inspired by our brain's neural network. So because our brain have some lot of neurons, and every neurons have some data. For example, if you see that new thing, for example, apple or orange, anything. Okay, if you are see the apple first time, so you can predict the shape, you can analyze the shape, and you can analyze the color, and this shape and color, this data are stored in our mind neuron, in our brain's neuron. All the neurons can get a this data, means it's a red color and this is shape, like that. Okay, so and someone telling you that is the apple, so that means answer, that is a label, that a red color and the shape is the features, and the apple is a name, so there is a label. Okay, so this label, that name also fixed in our neurons. Okay, so now our all the neurons are trained with that features and the label, and after some time if you will see the same apple in another time. Okay, and that apple also have a some red color and the same shape. Okay, and these features are matched with our previous neurons. Okay, these details also go to the neuron, and our neuron already have the details about that. Okay, so it will compare, and finally it give a label like apple, like orange, like that. Okay, so it's a deep learning. Okay, so and deep learning means nothing, it's another one subset of machine learning. So machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning. Okay, so machine learning, so see, I'll give an example. So here is one person, so he would like to watch the movies. Okay, and uh, and either he can like the movie or dislike the movie based on the genre of that movie. If it is a love movie, or it's a horror movie, if it is a comedy movie, and if it's a sentimental movie, so he can like the movie or dislike the movie based on these types of genres. Okay, so and here I have one prediction. So x-axis and y-axis, and x-axis have some love genre, and y-axis have a comedy genre. Okay, so and it was varies from normal to high. Okay, so normal to high, and I will plot some data. So these are the movies. Okay, these are all the movies, this is one of the movie, and this is one of the movie, and these are all the green color dot are the movies. Okay, so that green color, it's mentioned it is a liked movie by him, so it's a liking movie. Okay, so because it have a some high level of comedy genre and high level of love genre, so that's why, so he like these types of movies. Okay, so and next he have some disliked movies also. So and it was placed in a normal love and normal comedy. Okay, so if it is a normal love and normal comedy means, so that was disliked movie by him. Okay, and next, so he watched a new another one movie, so it was placed on the middle order of love and middle order of comedy. Okay, so now we need to analyze, is this liked movie or disliked movie. Okay, so because it has a medium genre of love and medium genre of comedy, so as per our human knowledge, so we can easily understand, we can easily predict. So definitely it was liked by him, so because it have a normal love and normal comedy movie. Okay, so but how the machines can understand the new movie? Okay, so it's simple. So first we need to create one circle using by the some algorithms. I will explain about it later. So some algorithms, so we need to draw one circle, and inside of that circle, so they have a four number of movies, and in that four, three movies are in a liked movie and one movie in a disliked movie. Okay, so based on the highest one, so we can fix it, this movie definitely liked by him. Okay, so because there are three number of green dots and only one number of red dots, so that's why, so it's definitely liked by him. Okay, so and this is one of the algorithm, so that's called KNN algorithm, K nearest neighbor algorithm. Okay, so now the machine can easily predict the liked movie or disliked movie based on the previous data sets. So these are the previous data set, these red color dots and green color dots are the previous data sets. So based on these data sets, the machines can predict the answer of new movie. Okay, so that's called artificial intelligence. Okay, so and in that machine learning we have a three methods. First one is a supervised learning, and then unsupervised learning, and reinforcement learning. Okay, so I will explain about these three. Supervised learning, so supervised learning means as like that name supervised, it's under supervision, it's working under the guidance, so we have some guidance, it will process under the guidance. Okay, so for example, so see here, so here I'm have some datas. Okay, some features, some clues. So because I have one questions, you need to predict you need to identify the player. Okay, so I'm asking you, you need to identify the player. Okay, and I will give you some details about that player. You need to give the name, you need to tell the name about the player. Okay, so the details are IPL and yellow and captain and wicket keeper. We need to predict the player, we need to identify the player. So as a human being, so because we have some data about that IPL and some players, we have some idea. Okay, so based on that idea, we can easily predict, we can easily identify that player within a second, so as per human being, but that machines need to analyze that. Okay, so first the IPL and yellow and captain and wicket keeper, so these are the features, and then I give the answer, so that answer is called as a label. I give answer as a Dhoni, so this Dhoni is a label, and IPL yellow captain wicket keeper is the features. Based on that features, the machines need to identify the player. Okay, so because these are the data, so in this supervised learning, we already give a features under the label to the machines for training process. Okay, so we give us some clues as well as the answer to the machine, so that's called supervised learning. Okay, so it's like if I'm given another one data. Okay, so the same features like IPL blue captain and batsman, so these are the another some datas, and I will give a label for these datas as a Rohit. Okay, so now these features, these datas are the feature and this Rohit is a label. Okay, now the machines can understanding, can trained with this type, two types of datas. Okay, so and after the training process, if you are asking one question to the machine, like you need to find the player, so and feature are, so yellow captain and IPL. Okay, so you only give it three features and it will match with the previous datas. So because we already give a data, these datas to the machines, that machines already well trained with these datas. Okay, so IPL yellow captain, this is our questions, these are our input questions, but we don't know about the label, and these input features are compared with the previous data set, and this previous data sets already have a label as Dhoni. Okay, and it will give the answer as a Dhoni. So because this input features are matching with the Dhoni's features, so that's why it's give a Dhoni as an answer. Okay, so this is a supervised learning. In supervised learning, we already give a labels and feature to the machine. That is very important. So and next, unsupervised learning. So it's direct opposite with the supervised learning. So because there is no any supervision, there is no any guidance for the process. Okay, simple. So here I have one image, and in this image we have some details, only details. The details are so there are some persons are there, and some persons are wearing a yellow color jersey, and some persons are wearing the blue color jersey, and some persons wearing orange red color jersey. Okay, so red color jersey. So here there is no any labels, there have only features. Features means it's a color are only the features. Okay, so and if you are give this image to the machine can easily split the data, group the data. So because there is no any labels, that have only the features, so based on the feature similarity, so it can group the input images. It will group the image. For example, if that machine was taking a yellow color as a feature means, so it will split the yellow persons for one group, and it's take a blue color as another one feature. Okay, and there are some persons are wearing blue color, so based on that blue color they will group under the blue feature. Okay, so there is no any labels, there is no any guidance. So based on the feature similarity, so it can split, it can group the datas. So that is why we call this a unsupervised learning. Okay, so and then deep learning. So I already told you have a three methods, and another one is a reinforcement learning. So reinforcement learning, it was simple. So simply it was working, it was process under the feedback. Okay, and this reinforcement learning is mostly using in a robotics field. Okay, so that's called reinforcement. It will learn from the errors, it will learn from the error. Okay, so that's why we call there is a reinforcement learning. So it's no need at all. Okay, so and next we enter into the deep learning. So deep learning, as I'm told already, it was inspired by the structure of functions of the human brain, structure and functions of the human brain. Okay, so because this is our human brain, so this is our human brain, and in this human brain we have a lot of neurons, and every neurons are connected with each and every other neurons. Okay, and if you see any one of the input data, any one of the object means, so our brain can understand the features of that object, and that features, that color, that shape, this all the data are called as the features. So these features are stored in every neuron in our brain, and after sometimes if you will see the same thing, so it will also given to the neurons as a input. Okay, so based on this mechanism only, so we can identify, we can recognize the all the things, whether it is a language or word or anything, person or object's name. So these all the things are only happened by this neural network. Okay, so every human have a billion tons of neurons in our brain. Okay, and our memory power is only based on our neurons count. Okay, so this is the normal human brain's neural network. In this neural network, every neurons are communicate with each other neurons, and finally it give a some output. That output was exploited by our mouth or some hands or anything. Okay, so as like that, we need to create another one neural network with artificially, that's called artificial neural network. We need to create the artificial neural network. Okay, so it's not a natural, it's artificial neural network, so that's why we called this a ANN, artificial neural network. And here we have some neurons. So these each and every dots are mentioned as every circles are mentioned as a neurons. So these are some neurons, and these are some neurons, and these are some neurons. There is a lot of neurons, and these neurons are splitted with some layers. So some of neurons are under the input layer and hidden layer and output layer. So there is three is very important: input layer, hidden layer, and output layer. Okay, so this is the process of deep learning, and I will explain about the machine learning versus deep learning. Okay, so machine learning means so it's simple. For machine learning, we need to give a feature extraction process and the classification process, and then only we can get an output. Okay, but in a deep learning, that feature extraction process and the classification process are same under the neural network, so we don't need any separated process. Okay, so and see, so these are some factors, factors differentiations between ML and DL. The first factor is data requirements. As I'm told already, if you have a less amount of data, we can get exact output from a machine learning. But if you have a lot of data, if you have a huge amount of data, a massive amount of data means, so we can't give these data into the machine learning. So because it has some low memory power and it has some low processing, so we need a deep learning for training the massive amount of data. Okay, so and next, computational power. So the first factor, data requirements, it gives us second factors, computational power. Okay, so for example, machine learning, if you take a machine learning, it's only based on the normal algorithms and normal processing. Okay, so that's why it requires only the low performance processors. So the CPU is enough for machine learning training or testing anything. But in deep learning, we need to create a neural network. Okay, so for creating a neural network, for training a neural network, so which requires a graphical processor, graphical processing unit, so which have thousands of cores as compared to CPU, normal CPU. Okay, so but the one disadvantage of GPU is so it's more expensive when you compare with normal CPU. Okay, so next, performance time. So training time of the neural networks take hours or even months to train the data. For example, if you are given a lot of images or a lot of videos as a data set means, so it will definitely take a month. Okay, and it's totally, it depends upon the amount of data and number of datas and number of layers of the network. Okay, so it's take a long time for training the neural networks when we compare with normal machine learning. Okay, so and next, accuracy. So this accuracy, so definitely the deep learning gives us a higher accuracy because it's based on the neural network and it have some lot of data sets. So that's why this deep learning gives us a high level accuracy when we compare with normal machine learning process. Okay, so and the input. So input for machine learning and deep learning, we need to give a features and algorithms, and some of the deep learning algorithms created the automatic model. So it's created the model automatically. Okay, so and next, some advantage of deep learning. So best result with unstructured data and no need for labeling the data, and deliver the high quality results, and there's a lot of advantages are there. Okay, so and these are the some challenges. So too much data to analyze, it requires the lot of data. And next, neural networks are essentially in a black box. So black box, why we called this neural networks in a black box means, so it's simple. So because the most popular researchers also cannot get the exact process of the neural network. So that's why the neural network are in black box till now. Okay, so and next, it requires a high performance hardware. So it's like our GPU. Okay. So and next, where we use the this artificial intelligence. So this is the applications of artificial intelligence. Okay. So first, um, translator. Okay. So translator, so we all know about the translators. So in our mobile phone and in our some websites and some PCs like that. So translator, so for example, consider if you have some huge amount of data, if you want some informations, so definitely we are also going to the internet and we are searching with some keywords. Okay, and this website gives us a informations, but this all the information is particularly in a own language, the common language English. Okay, so but you want these informations in your own natural language means, so we need to convert this English language into our natural language. Okay, so for this process, so we need a artificial intelligence, so we need a more amount of data for training. Okay, so if you are training a more amount of data means definitely we need a deep learning, and this deep learning is under the artificial intelligence. Okay, and now all the Google translator, so we all know about the Google translator, no? So Google translator, so if you are if you are getting some information from the Google and you want the informations in another language means, you can simply go to the settings and you can change that language, and this whole web page are translated to the other language within a second. Okay, so this process is only happened by artificial intelligence. So and next, customer support, customer care. Okay, so when most of the people's converse with customer support agents, and we are also have some experience about the customer care conversations, no? So you see that conversations is looks like real, and we also don't realize the it's actually a robot on the other side, so we can't identify that. So because it's opposite as a machine, it's a robo. That robo can understand your voice, understand your thoughts, so using by natural language processing, understand your language, understand your informations, and it will replay within a second. Okay, and this all the process is only done by artificial intelligence. Okay, so and next, self-driving cars. If you take a self-driving cars, for example, um, so the driving process, it's one of the some hard process for human also. Okay, so for driving, so we need some more informations about the road signs and about the vehicles. Okay, so and about the speed and about the road facilities. Okay, so we are the humans, we also need some more knowledge to drive the car or some vehicles. Okay, so but the machine, if you take a automatic vehicle, if you take a self-driving cars means that machines also need these types of informations, like road signs and speed breakers. It's need to identify the speed breakers, and some pedestrian crossing. Okay, so and the line of the road and the speed and the gears and the horn. So this, for these all the things we need some some more knowledge. Okay, so and this all the science fiction, this nowadays it's real, it's in a reality. Okay, so so it was happened in abroad, that automatic self-driving cars. So it's like some of the few companies like Apple, Tesla, and some Nissan. So so these are the some only few of the companies are working in self-driving cars. And this self-driving cars, for this self-driving cars we need a more number of data sets, and these all the data sets are trained to the machines. So for this process definitely we need a deep learning, and this deep learning is under the artificial intelligence. Okay, so but this self-driving cars, it's two faces some limitations. Okay, so some limitations, so that's why, so we can't get this self-driving car in a market till now. Okay, so and next, medical care. So medical care, so these neural networks, our normal artificial neural networks detects the cancer cells and analyze the MRI images to give a detailed results. So MRI images and some CT scan images, so these images have some very minute data. Okay, so they have a minute features, so the doctor cannot identify the exact features of the MRI scan image report. Okay, but for machines, so it can easily understand, so it will analyze each and every pixels of the image. Okay, so each and every pixels, so it can get the data from that pixels, and this data was compared with the previous data sets, and finally it gives us some results. These all the data and these all the process are only happened by the artificial intelligence. Okay, so and then there's a lot of examples are available in for artificial intelligence, but these are the some few examples. Okay, so and let's talk about the neural network. So this is our humans neural network now. So inputs and it gets us some output, so it's like, so these are the artificial neural network. So I will explain about it. Internet input layer, and this is the hidden layer and output layer. Okay, so consider this is the input layer. Okay, and here you have some image. Okay, so some image, and this all the image have some pixels now. So image means it's a group of pixels, and each and every pixels have some color. Okay, okay, so and this is the input layer, and here I'm generate the hidden layer. Okay, and this is also the hidden layer, and finally we have a output layer. This output layer depends on our labels. Okay, for example, so here I have a another one image. Okay, so we need to understand, we need to identify what the image is a X and which image have a O. So for XO identifications. Okay, so this image, consider this image have a X and this image have a O. Okay, so and this the neuron for X, and this is the neuron for O. Okay, so now I give this X image as a input to the machines. Okay, so and this pixel, this first pixel is give a input to the first input layers. Okay, and this second pixel, so it's given into the second neuron of input layer, and third pixel is given to the third neuron of input layer. Okay, so and this all the pixels are trained in an input layer. Okay, so and next, so it will added with some bias value and the weight values. Okay, so some calculations, seen some calculations, so these calculations, and after the calculations it gives us some values. Okay, so for example this pixel value is a 0.5 means, so after the calculations it gives a 0.6 or 0.7 like that means. Okay, so and it will connected to here. Okay, so and it was connected to here, and each and every neurons connected to other neurons. Okay, and it was connected to here. Okay, so and finally, and every neurons choosing one other neuron. Okay, so some see this last image, last neuron is only choose this image, this neuron. Okay, now in this 5, the 3 neurons are choosing, sorry, 4 neurons are choosing X, and 1 neurons are choosing 0. So because it, this all the neurons are trained with the X images, so that's why it choose the X. So the value of X is like 0.92, and this O it gets a 0.16 or 18 means. Okay, so finally we get these values for last input, sorry, output layer. Okay, so based on the highest one, so we can finalize the input image. Okay, for example, if you are give a 0, if you are give a 0 into the every neuron, so and after calculations that most of the neurons are choosing the 0 now. Okay, so now this will be converted into the 0.9 something, and this for 0.1 something. So based on that highest value, so we can finalize there is a 0. Okay, so it's a neural network process. So in between the input layer and the hidden layer and the output layer, so there's some calculations. So these calculations are the algorithms. Okay, so and so this is the input 1 and input 2, input 3. So perceptron, so this is called the perceptron means it's nothing, and the single neuron called as a perceptron. Okay, and every single neuron have a multiple inputs, and it generates only one output. Okay, so this output given into the other neurons. Okay, and these are the calculations. So it's the input neuron, and this is the input neuron, and this is the input neuron, and in between that neurons, so we need to add the weight. Okay, so weight means it's nothing, it's a priority. Okay, so it's a priority. That priority can increase the values. Okay, so and after these calculations we get some output, and this output was given into the other neurons. Okay, so finally, after I hope all of you have some knowledge about this artificial intelligence and deep learning and the machine learning. Okay, so and we need to talk with the machine, so that is very important here. So because we need to give the information to the machine, so because we need a communications like, so for communications definitely we need some language, but the machine knows only the programming languages, binary language, zeros and ones. But we humans we have some lot of languages. So if you take a English language, okay, so humans knows only the English language, but the machines knows only the binary language. That means the zeros and ones power supply. Okay, so we need to communicate with each other. Okay, so that's why definitely here we need a programming language means it's simple. It's an intermediation language between a human language and the machine language. Okay, so here we take a Python. So I hope all of you have a knowledge about the Python programming, so I will give a simple details. So it's an interpreted is a one of the translate. Okay, so and so when we compare with the other programming languages, that Python have a lot of module files, lot of facilities, a lot of features. So that's why it's take up first place in a the popular survey, Codable survey. So next syntax, when you compare with the syntax, so it was very easy than other languages. Okay, so and automatic memory management is one of the another one feature. And general purpose means, so we can use this programming language for each and every domain, so using by that module files. So because OpenCV is one of the module file, and Django is module file, and Pygame. So OpenCV, so we can easily get information about this logo from this logo. So red and green and blue RGB, so that is the primary colors. So this OpenCV is only for image processing. So we can do the image processing using by this Python programming language through the OpenCV module file. And next is Django. So Django is a web application module file. Okay, so and next Pygame, so it's like the name, so we can create the games using by this module file. And next Maya is one of the module file for creating animations and 3D. Okay, and these are the some few examples. There is a lot of module files are available in a Python program. Okay, so and using by this module files, there is a lot of companies are using Python programming for their own purpose. So NASA for using the Python programming for encryption decryption method, and next to Google and YouTube for recommendation, and IBM for cloud security, and Netflix also the recommendation system, and Quora for the web applications. So and the list goes on. Okay, so and we can easily download the Python programming from this website. Okay, so and we'll give a demo. Okay, so simple. So here I'm using the multi-layer perceptron algorithm. So MLP is one of the algorithm, multi-layer perceptron. So this is the applications for find out the forest and the coast. Okay, so we need to find out the image, exact image. Okay, so simple. So input, so in this input is our data set. Okay, so it's our previous data set, and it have a two folders. First one is for coast and another one for forest. So in this coast I have a 360 number of images. Okay, and these all the 360 numbers are in a coast images. Okay, so and next to the forest, so this also have a 328 image. So these are all the forest images. Okay, so and then I train the machines using by these input images. Okay, so next here I have a 4 image. So this is our input data. We need to identify so what is the exact result is this. Okay, so if I am give this image, means it's need to identify the coast or forest, and it's need to identify the forest or coast. Okay, so using by programming Python program. So here I'm open a Python program. Okay, so here I'm import the some module files like sklearn and some MLP classifiers and numpy and cv2. So OpenC module file, and numpy is a numerical Python. If you want more details about this module files and about this program means, so just to go through our previous videos, you can get a clear idea about the each and every lines. Okay, so otherwise if you want internships, or if you want some workshops means, so definitely so you can call our coordinators. Okay, so and so here for image we need to extract the data, extract the features. Okay, so for extract the features, here I'm using some functions, and these functions is using to extract the features from the image. Okay, so and after that I train the image using by this fit transforms. Okay, so and next using by the MLP classifier, that means multi-layer perceptron. Okay, so and after I give a input image 1f.jpg. This is our input image. We need a label of that 1f image. We need a label. So whether it is that is that a forest or is that a coast? So we need that. Okay. So and next RGB and features. So it's also calculated the features of our input image, and this is for the data set, and this is for our input image. Okay, and after finally we have a one predict. Okay, so prediction function. Okay, and I apply the test x means it's the features of our input image, and these features are given to the prediction in a model. That model is our MLP classifier model. Okay, so and after we get a predictions, so I print the predictions. So just I run that. So first time it takes some time for training process. Okay, so simple. So here I'm print the folder images. Okay, so first it's take a coast folder for training process. So I print all the labels of that image. So it's print the coast. Okay, so and next it's take a forest folder for process. So when I'm converted this normal coast and forest into the binary format, so that all the coast is converted into the 0 and all the forest is converted into the 1. So and this is our final output. So 1. So 1 means this is the forest. Okay, so 1 means it's a forest. Our input image is a forest. Okay, so 1f we'll check the image. So 1f it's a forest. Okay, so next I am give this image to C. Okay, so to C into the program. So let's see the output. Okay, so to C, and I just run that. So it will print coast and forest and binary format and the 0. So 0 means it's a coast. Okay, so 0 means it's a coast. So it's predict the image based on our previous data set. Okay, so it's one of the example. Okay, it's image oriented example. And next tell about the credit card fraud detection. So because it's very important, so it have some features. Okay, so these are all the features. So ATM pin number and card number, user signature and CVV and bank name. Okay, so and bank code and bank IFSC code and bank pin code. So these all are the features. Okay, so using by these features we need to analyze whether it is a fraud card or normal card. Okay, genuine card. We need to identify the fraud transaction and genuine transaction. So this all the 0 is mentioned as a genuine transaction and 1 is mentioned as a fraud transaction. Okay, so let's see the number of data sets. So it have a 18,321 datas. Okay, the features, the number of features or the 31 features, number of 31 features, and it have a 591 of datas, number of datas 591. Okay, so for these types of huge amount data, so we need a CNN, so we need a deep planning. So in this deep planning, so we call the CNN algorithm for prediction. Okay, so and here I'm called the CRID.csv is our data set, and this data set was trained to the machine. Okay, so this fit is used to training process, and after that here I'm take another one module, sorry, another one Excel format file. So this test.csv, so let's see the test.csv. So this is our input features. Okay, so we need to identify the label for this input feature. So this feature is this genuine or fraud, we need to detect that. So that's why I read the test CSV file and I give this test file into the predict function of model CNN. Okay, so and let's see. So it's based on a TensorFlow, because for creating a neural network definitely we need this TensorFlow and the Keras. So it's compare the previous neurons for 200th time, and it gives us some values as like okay, so these are locations. So kindly give your review and feedback and rating for this video in that link, particular link. So I request to all of you kindly give your feedback. Okay, so and if you have a questions related to that, so just mention it in a chat box, otherwise in a comment sections I will reply as soon as possible. Okay, and some of people's requiring the Python. So this is the Python file, Python link. Okay, so we can download the Python from the python.org. Okay, so python.org. Okay, so in this download you can choose your OS. So here I'm click a Windows, and in Windows you have two generations, third generation and second generations. So you can download the any one of the generations. Okay, so if your system is in a 64-bit means you need to download this hyphen 64 executable installer. So otherwise you can install 86 executable installer. That's it. Okay guys, I expect your reviews in that particular link. Okay, so and I once again I thank you all of the participants here. Okay, and the T.John College and the Department of Computer Applications, and the Honorable Head of the Department Dr. P. Felsi Judith Ma'am, and Assistant Professor J. Prabha Madam, Computer Applications Department. Okay, so and the management of T.John College, Bangalore. So thank you all of you.